morning, everyone. It's Blair Abernethy here again, software analyst with Rosenblatt at our fifth annual AI conference August session. With us this morning is Babak Taheri, who is the CEO of Silvaco. Silvaco being a small cap EDA and TCAD software, sort of technical, plays in the technical tools space. So, with that, Babak, I wonder if you could just give us a couple of minutes on your business, just a general overview, sort of the end markets that you address, and a little bit about your background as well for the audience to understand sort of where you're coming from.
Absolutely. Thank you very much, Blair. Good morning, everyone. We've been in the industry since 1984, and the company hired new managers in order to make it less of a scientific lifestyle company to a real company. After 5 or 6 years, when I joined in 2019, we took the company IPO around 2024. Back in May of 2024. Matter of fact, in 2024, our bookings were about 65.8. Our revenue was about 60 million, 10% growth for revenue, 13% booking. We were participating in $3.8 billion of SAM for our industry. As you know, we are considered to be an EDA company, the likes of Synopsys, Cadence, and Siemens, Mentor Graphics. So we have 3 business units. We have a business unit that sells the traditional electronic design automation tools, such as any electronics software that you need in order to design a chip or an IP. We do have what's called a technology CAD software that enables you to design any new thing in terms of process or any new devices that require new material analysis and translation of that into models that you can actually simulate. We call those nowadays digital twin models, and also a semiconductor IP company. So also this year alone, we've acquired 3 new companies. Based on that and our growth in our inorganic and organic together, right now we've added another $710 million of SAM to our market. The company is expected to grow double-digit this year and be neutral in terms of profitability. That's putting things at the high level, Blair.
Okay, that's great, Babak. So let's maybe start off on your core TCAD part of your business, which is give or take half your business, I guess. Yeah, so how are you positioned there versus your major competitor, Synopsys, and sort of what's the value proposition here for customers? Why do they buy this software? And how do you grow within that marketplace?
That's a very good question, Blair. Our technology CAD software is a fundamental software that we started the company. The company started based on that technology that was licensed from Stanford University. The technology is such that as you know, the chip complexity and photonics complexity is increasing. You need to pack more chips into it. You need to add new materials into it. You need to get to market faster. And when you start adding things like new materials, like if you're going from bulk CMOS semiconductors, as they call it, down to technology nodes, down to 2 nanometers. If you travel that journey down to FinFET, gate-all-around, nanosheets, and also angstrom level simulation, you find out that new materials come into picture to make the sandwich layers of a wafer that form transistors and circuits. Whenever you do have additional material, their properties are not well understood. So technology CAD is, if you think of it as a fundamental simulation model, which has physics simulation. We call that multi-physics, not only physics, but also in terms of thermal management, optical. Actually, believe it or not, there's a lot of optical characteristics of these material that need to be looked at, thermal and material properties that to be looked at. And TCAD fundamentally enables going to the next node, going to add a quantum dots on your LEDs to make a screen that's called QLEDs. getting into new power devices like GaN or silicon carbide. Any new materials that come into picture, TCAD is a must-have in order to do simulations, not run expensive wafers, in order to do the design of experiment analysis. So TCAD is fundamental to any new material or anything that comes up. Our software enables our customers to do that. As a matter of fact, we have lead positions in power market, GaN or silicon carbide, if you will, photonics in terms of displays and other photonics like image sensors. And you think of memory as well. We are pretty much leader in terms of supporting that market going forward. In terms of our TCAD as a whole market positioning, we are number 2 in the world. There are no other companies that provide full solutions besides us and one of our bigger competitors. As it turns out, that we have such a vertical markets leadership that the accumulation of that right now positions us in number 2 in the world. However, we've introduced what we call FTCO, Fab Technological Optimization, that uses AI. So TCAD historically has been used for design portion of chips, the designing of the process to design the chips. But traditionally, that has been the case. What we have done as of last year when we announced, we've actually moved TCAD to be very useful in terms of augmenting it with statistics and analytics of AI. We're able to help manufacturers go through all this data and be able to simulate, enhance yield, get to market faster, not run so many simulations that takes months to years to actually to do, but rather do them quickly, not run wafers that you waste a lot of sunk cost for the manufacturers, which is critical. So we've taken it to this new market we call basically fab technology. And we are the only ones in that white space using TCAD for production level simulations and digital twin models. And as a matter of fact, when we talked last time, I mentioned that we've added another $500 million of SAM to our market based on that. That basically doubles the total market for TCAD. And as we progress, we are pushing very hard to get our products accepted both in design and fab, so that we can hopefully with our efforts we can become number 1 in the world.
Thank you. And the FTCO has you've really had that in the market for what, less than a year almost. What's the first couple of customers, what's been their experience with it? What's are they driving value off of it? And I guess also you're typically selling TCAD into the early stage experimentation or design, and the research side of product development. Is FTCO a little further along in the food chain?
Oh, much more. As you recall, we went to IPO on June. On May, we announced we had Micron as our main and first customer for it. Then we showed also that our relationship got extended, because every time you have a new device that you want to mass produce in a new fab or a new lane within the fab, you require additional R&D, and that's what we follow up with. The first thing that, matter of fact, FTCO requires you to do is use our TCAD, or what we call design technological optimization tools. Then you add analytics and statistics, and that combination makes an FTCO, which is an enabler for manufacturing. And as a matter of fact, also in our last call, we mentioned that the first stage of FTCO customer acquisition is doing R&D with them, not for them, but with them. And we said that we do have advanced CMOS fabs that are in the R&D phase with us. We mentioned that we have also power electronics companies that are in the R&D phase of FTCO with us. And going from the R&D phase, which makes sure that all the bells and whistles of the product is there for manufacturing, takes between 1 to 2 years typically. And then beyond that, then you go to what we call manufacturing phase, which is where those are the much larger deals we do, because we've changed also our business model from selling seats to designers, one seat per design. We're actually, when we get into fab manufacturing, we sell seats per lane or per fab, which commands a much higher complexity of simulations, digital twin modeling, and that's where we are at with FTCO. We consider it to be very successful. A lot of it, some of the delays that we've seen over time is because of the fact that these tools to get adapted and to have a manufacturer, a fab lane, which could cost in the orders of hundreds of millions of dollars to make a chip, it's very expensive to just experiment. The R&D phase of what we do with FTC is to make sure that they run examples of what's in the fab before they launch these in the fab. So that's the process we're learning. That's the process our customers are learning. We're the first one in the market with it. So that learning cycle has taken a bit of time, but we have quite a bit of tailwinds in this technology. It's very unique. It solves a lot of running wafer waste, masks waste, and as you know, as you go down the FinFET and below technology nodes, you end up paying tens of millions of dollars per mask layers, and each of these, depending on the chips, could have hundreds of masking layers, but 1,000 processed in terms of the memory. So you find out that it's very expensive to make these wafers and experiment to see which parameters you need to yield them. However, if you have a simulation software that can do that for you, which is the premise and actually delivered results on FTCO, that's what they're looking for. So.
It's I know it's very early still in with this FTCO product, but do you have any indications as to the what kind of value the customers are getting out of this? How much do you think they can save? Or with software, you've always got to look at if I'm going to spend $1 million on it, what's my payback on that investment?
No, that's an excellent question. And frankly, you find that people in manufacturing think about cost very differently than people in design. People in manufacturers, if you are making a large memory company, you look at every penny that contributes to the cost of making those chips. So unless the ROI is justifiable, they won't even consider this. And I'll give you a feel for it. Think of a manufacturer that runs, let's say for now, a 20 nanometer. Not even go down below that. 20 nanometer wafers or 10 nanometer wafers for that matter. As an example, you find out that the wafer cost is about $10,000 to $20,000 depending on the product. The mask cost exceeds tens of millions of dollars. And manufacturers, in order to fine-tune their processes and the tools, right? They have tens of tools that they have to process these. As I said, 1,000 process steps. They have to process these wafers through, and it's expensive. So you find out that if you can save them 10 wafer runs and 2 or 4 mask sets, that could add up to hundreds of millions of dollars of savings. So the ROI for the software resale is very justifiable to them and to their management. And matter of fact, if they can get the product out 6 months sooner, and if this can help them put the next generation out 6 months sooner, so I would call it a piece of cake. I should put a lack of a better term. It's very easy to justify to the company, to the management, to manufacturers, to their COO, to get this software.
So that's really helpful, Babak. And just to help us understand what you've publicly disclosed so far, Micron was the first customer to take this down. How many are sort of piloting or in your pipeline, or trying to understand how big this opportunity could be for Silvaco.
Yeah, so we've said historically we've added $500 million of SAM. And we would like to capture anything in the order of 10 to 15% of that in the first 3 to 5 years of the introduction. And we are in the second year of introduction. We introduced it in May last year in manufacturing, not in R&D. And I've said before, we were in 3 years with R&D with Micron before we got it into manufacturing. So now that we've done our first one and we're doing our second and third one in power and advanced CMOS, that those learning cycles have improved drastically. So the R&D phase are shorter. And that's our goal. Our goal is get to 10-15% of that market within 3 to 5 years.
Okay. All right. That's really helpful. Okay. Shifting gears to inorganic growth. So this year you have made 3 acquisitions. Maybe you could just walk us through, what you bought, why you bought it. And I guess it's a little early to say how are they going because 2 of them have just closed in the last 60 days. But you've made some strategic moves, and maybe give us some color behind that.
That's a great question, and we've actually done 3 acquisitions in the time frame of 3 months. It's unheard of, right? Before when we went to the roadshow, they asked us whether we could do acquisition, how fast can we integrate it, right? And the proof is in the pudding. We've done 3 acquisitions. 2 of them are fully integrated. The third one we just acquired a couple of weeks ago. It's getting integrated. So I expect the integration of these 3 should be completed by I would say end of September. But when I say integration, the staff are on board. Everyone's using the same IT baselines that we have. Everyone's using the same tool methodology. But we found out that acquisition, especially if they are non-public company, cash-based, challenges come when you have to go and convert their financials into ASC 606, and that takes longer time than technical portion. So we're in the middle of that and getting that done. And a matter of fact, I'll tell you about the strategy of acquisitions. It was very key for us to get those done because let me see if I can share one screen video, Blair. And by the way, this is already on our page. I don't know if you can see it right now or not.
Yep, that's good.
Great. So if we make this bigger, you'll see that I've always said this, to make a final chip, you have to go through a design step, a wafer fab step, a packaging step, and a testing phase, and then the final chip, whatever else you need to do in order. If you have requirements for automotive, you have to burn them in, you have to test them differently, and those things happen at the final chip level. You'll find out that we have and other EDA vendors have focused for the past 40 years on design. One thing that we added just most recently, I'm starting the acquisitions from most recent to first, was Mixel. It's a mixed signal IP. They're one of the world leaders in making MIPI IP for automotive. And that acquisition was completed, and we've added about $110 million of market share for us. And that's enabling us to grow our IP business unit at a much faster pace. And this year we've said we would add anywhere from $2 to $4 million of revenue just because of Mixel, because we just finished acquisition. More than there's only 5 months in the year left, and that actually helps us increase in our presence in the design space. Then before that, we acquired a company called TechX. TechX, we showed in our last slides that does 2 things for us. One, in our FTCO, it helps us with the wafer fab portion, digital twin modeling, because it's TechX enables us to not only do digital twin models of smaller components, but also can actually simulate the performance of things like how do you etch this wafer. So etch, for example, plasma etch, which is the most popular etch profile disease for advanced nodes. How this profile looks like over the full wafer, not a die, not a transistor, but over the full wafer, which takes us to the next level of FTCO, which we are incorporating into our FTCO. So not only by itself we can sell those products, but also integrating them as part of our platforms enables us to go after solving bigger problems, which is the reason for our existence. We always love to solve the most difficult problems that comes on our way. So TechX, besides the FTCO combination, TechX also fills out the Lego blocks for our photonics offerings. We had mentioned many times that we are in photonics market. We had mentioned many times that photonics integrated circuits are big, and the component we were missing was a component that was provided by TechX, which is a finite difference technology, or I would say the algorithm method by which you can run simulations on AI-based microprocessors, graphics processors that can really compete well and surpass everyone's performance in terms of accuracy and speed. And that's the component we were missing. Adding those have helped us complete our jigsaw puzzle for photonics. So you'll see our presence more so in the photonics market. And again, these are partly to get revenue this year from the existing customer, land more customers and expanding them. So we've basically, with these two acquisitions I've shown you, we've teed up really well. We're teed up well for the next year because that's where a lot of the new customers, new expansions come in. And in photonics, as you know, again, it takes the same steps as electronics, except you have to use different kinds of software, different kinds of behavior. And because photonics and electronics behave differently, and at times you have to simulate them together. That's what we call multiphysics, going from photons to electrons and conversions back and forth, dealing with waveguides, dealing with circuits. That's what this is all about. And this alone by itself has also added a total of $260 million to our market. Part of it, as I mentioned, is photonics integrated circuit, which is $115 million market. And then FTCO portion, we should call it fab here, is another $145 million. So these are the latest two acquisitions done in the last month and a half. And prior to that, we acquired what we call PPC, or it's basically proximity correction for masks. So that's where you transfer designs into wafer through a mask, which happens in that step. And we actually acquired the OPC technology from Cadence, and that gets us into the market where we can actually take that technology into the next stages of evolution of OPC or PPC, as you call it, to make masks. All the mask corrections happen in two dimensions, X and Y. And those are done because when light goes through the mask, hits the wafer, it comes back, reflects, refracts, and those basically calls for aberrations that creates problems. What you print out doesn't come out is what you want to be on the wafer. So those are yield problems. Mask corrections like PPC and OPC take care of that, and two dimensions. So anything that needs to be adjusted in order to correct for those reflections and refractions, that takes care of. Where we are taking this now, since we have TCAD, we are enabling in the third dimension correction. With TCAD, since we can simulate actually what you print, what shows up on the wafer, we actually can pre-simulate this and see the impact of it before they make wafers. So we can actually do the correction in the mask on the third dimension, which is where we are taking this technology. Very excited about it. And actually, every time I see how progress is being made here, combining TCAD with OPC in order to go to the third dimension is very powerful for us. And that's where we're taking it. We already have customers in that domain. We've actually said we've actually had over $2.6, $2.7 million of revenue from it, and we continue from the existing customers to have more revenue from it and expand it into the new markets with the new technology and new customers. So that's the ballpark of what we did for the last three acquisitions. And again, I want to emphasize, this was not only to buy talent and technology, but also buy revenue with the potential of high expansion. And we are hoping that as soon as we finish our integration of these three companies by September, the next quarter when we do our call, we can also keep track of, which is very near and dear to my heart, keep track of ROIC, right? How much ROI you get from the cash or from the investment you've had with these acquisitions. And that's a metric we have never reported, but as we finish our acquisition integration, I'm hoping to get that done also, if not in Q3, but in Q4.
Interesting. This Cadence acquisition you made. I want to ask you a couple things here. Just to clarify that. So, was it Cadence that came to you guys, or you came to them, or you both sort of saw that maybe it would work better with a TCAD owner? Because I would think also though that the proximity compensation correction is almost more of a manufacturing side of the equation than on the design team, the R team.
Right.
Like TCAD is. So can you just help us understand that?
Yeah. As I mentioned, we had historically focused only on design portion. If we did not have FTCO, and because FTCO takes TCAD into manufacturing, so we can do certain things about process, the actual manufacturing process, which corrects everything. But the first step of manufacturing is what? Is making masks to expose wafers, photoresist to different kinds of light sources to make, manufacturing of wafers is like bricklaying, right? You put a layer of cement, then you put the brick, you put a different layer of cement, you do your changes if you want to make a window or door. So the same thing in manufacturing of wafers. You put down the photoresist, we call it depanage. You deposit something, photoresist, and then you expose it through mask and you etch it. Depanage. Those are the main steps of manufacturing of wafers. So the first step being mask, you find out that there is a lot of aberrations and errors gets introduced by masks when they get into advanced node. So we said we have the design portion done, we have the manufacturing portion done, all the process and device steps. What we don't have is the first step, which is mask making, and we've never been in there. And unless you have other technologies to complement what exists, you can't take it to the next level. You have to be an ASML, right? The biggest, I would say, provider of masks is ASML, right? Or mask corrections is ASML. And for us to compete and be able to get to that, we have to have had complementary technologies to enable us to help correcting the first step of manufacturing, which is mask making. So with TCAD combination as well as existing PPC and OPC and the new algorithms we are justifying is basically where we are taking this. And if we did not see a way for us to basically go and expand, a way to improve and enhance based on our technology, we would not have done this acquisition. And as the first portion of your question, did they come to us? Or they did come to us. Matter of fact, the nice thing about this technology is 3 of their largest customers turn out to be our customers as well. And when Cadence had told them they want to sell this product, their customers recommended that they come to us. So that's how the process started. And there were other suitors, but it turns out that we were the best match and the best way the team thought we could expand what they have, and that's how it worked out.
That's great. That's great. Thanks for the clarity. Maybe we take the conversation up just a level here and talk a little bit about the some of the market trends in EDA and in simulation, multi-physics simulation. Sort of, what are kind of the major drivers out there now that you're seeing, and sort of how are you responding to them?
No, absolutely. And we have talked about this many times, but it's always good to show a slide that I've always also shown in our presentations in the past. If you think of it, I mentioned already increasing complexity of chips and photonics, new materials introduction, go-to-market challenges. Now, you think of wanting to manufacture very high complexity chips and photonics, that's challenging, right? There's problems worth solving, right? And then in order to that, you find out that this complexity of requirements surpasses the memory, the high performance compute, photonics, compute, automotive, every aspect of our life, I would say, right? And I've named some, and the acquisitions that we did actually improves on our presence in the markets that I've done dashed orange lines on. But you find out that for complexity, all those markets get impacted. For new material, all these markets get impacted. And any of these devices or circuits or photonics that needs to get to market require you to have a new set of rules, new set of simulations, new set of digital twin models. And as you know, in the old days, it started at one transistor simulation. Now it's gone to the full chip. Now it's going to wafer level. Now it's going to basically what I would call a system level simulation. And you find out that all of these are needed, capabilities are needed to be able to do, I would say, digital twin and simulations of bigger and larger systems in order to get us where we are.
Okay, great. And your if you kind of I want to shift and talk about one of your markets for a minute, which is China. So China's had a lot of change in the market for EDA vendors in the last 2 years. What is Silvaco seeing in that market, and where are the opportunities for you there?
That's a very exciting and dynamic market based on geopolitics of it, based on performance of it, based on technology part of it. And as you know, there were quite a bit of news a few months back in terms of involvement of the government in this space, prohibiting EDA software tools to be shipped, and then it was reversed. And then certain things were prohibited to be shipped. Now it's reversed. The good news is that this technical collaboration, I think, is very healthy. We've always had about, I would say, 15 to 20% of our revenue coming from China. We see that still going and perhaps growing based on the less limitations that we are exposed to. And the nice thing about it is that market is growing very fast, and we are part of it. We will end up to be a bigger part of it. Matter of fact, if you think of our TCAD and automotive, as well as photonics and power, and those are the areas we're growing in China, and we will continue to grow. So, and I think it's a healthy market to be participating in, as long as we follow the processes that are acceptable to everyone. So,
Is that market been a better market for you this year than last year?
Well, if you had asked me this question 6 months ago, I would have said no. But now, yes. Yes. It's very dynamic. That's what keeps us on our toes, right? You've seen our bigger competitors were dropping their estimates based on the fact that they didn't look good 6 months ago, but now it's different. So we'll all see how that goes and monitor it.
So. Yeah. Okay. The other area, I just want to touch on this briefly, but you do, obviously, your TCAD business is very advanced technology, as you said, working with new materials, a very early stage. You do a lot in photonics. Is there an opportunity in quantum computing for Silvaco? Is that something that you're watching, or you can do something with your TCAD technology?
Oh, absolutely. Not only TCAD, but also EDA and as well as IP. Matter of fact, we have two photonics customers. No, not photonics, sorry. Two customers that do quantum computing, and one of them not only uses our TCAD, but also our modeling services for IC design. As it turns out, a lot of these companies require new material. Not many circuits could have been modeled at 4 degrees Kelvin, right? The models did not exist. We had to generate those for those customers. Not many circuits can go the boundary of optics to electronics, because you find out that at some point in time, the frequency bandwidth required to go to that boundary of electronics to electronics, it becomes so high and so power hungry. We had to provide solutions in terms of TCAD and IC and coming up, I think, IP also solutions. So it's been always, we've been there for the past 5 years with them, and we will be there for the next 30 years. Hopefully they have a quantum computer with 2048 qubits that that everyone can utilize and succeed in. But to me, it's a long-term journey. It's not something that's going to come and go. It's been going on for a while, and it will go on.
Have you seen increased investment there in the last a couple of years?
Oh, yeah. Absolutely. Yeah, I mean, look at the companies that are private and public. You can see from their stock. You can see how much capital was raised. As a matter of fact, there was an announcement a few months back. There is a quantum computing company in Palo Alto that raised over $450 million just recently. So you'll see quite a few of them are doing it. It's a very hot topic, and God help whomever that falls behind that technology. So it's something that if we don't keep tap into it and don't grow at it and solve it, we would fall behind drastically, and that would not be a good thing for us. So.
Yeah, interesting. On the TechX acquisition you made is a lot of it's in the simulation market. The technology. What would you be, what's sort of your strategy in simulation? Because, if I look at Synopsys acquired Ansys a month or so back, Cadence has been building a lot of simulation capabilities. What's Silvaco's positioning in this space?
Yeah, if you look at our bigger competitors, they tend to focus on system-level simulations. For example, Ansys was really good at simulating engines of a car, right? Their bigger competitor is Dassault. They simulate or remodel the whole airplane, right? They actually make airplanes. So they're getting into bigger and bigger systems. Cadence also acquired Beta CAE. I think that's what you were referring to. Beta CAE enables them to do system level simulation as well. The difference between them and us is we've always said, if you look at the physical world, if you look at the city, the airplanes, the cars, those are the sort of thing that other companies are focusing on. What we really focus on is things at the wafer level and below, to the atomistic level. We call, our tagline is from atoms to systems, and our system right now stops at the chamber level in a manufacturing site, or at an optical module. That's where we are at, and our premise and philosophy has been always to build that up to a level that basically gets us to a very deep understanding of. And I mean it by atomistic level, physics simulations, doing green functions, doing mass transport functions, all the way up to what a wafer work looks like, mechanical, thermal. I mean, if we are not there yet, we are probably 80% there. We have 20% more to go to really get to where we can solve a lot more problem in manufacturing. And when we're comfortable with that, then we look at where else can we focus on that we can lead, right? We have to have modes, right? And this is FTCO is one of our modes. Our next mode is where we're taking PICs to, right? The photonics integrated circuit. So we're looking for the next mode that hopefully we can announce some next year that we can differentiate and have products there, so that like I call our bigger competitors our bigger brothers. We all are working towards expanding the market, not necessarily have a head-on competition, and that's my goal. My goal in the industry is to be able to expand markets, solve newer problems, more difficult problems, and that's what we're here for.
Got it. No, that's very clear. That's helpful because you're really, because of the TCAD core technology of your platform, there's lots of simulation required around that level of technology research. And so, as opposed to, as you said, you're not talking about wind tunnels for aircraft wings or cars. It's very, Can I ask you just the same sort of question around your IP business? So Silvaco has always had some IP. It's been anywhere from 5 to 10% of your revenue. You had a relationship with NXP and their portfolio. Just talk about Babak a little bit about what's Silvaco's strategy around IP and how important is it to, or how big do you think it will be?
That's a great question, Blair. You're right. Our IP business has in between 5 to 15%, depending on our deals during the years. We share And our strategy was initially to, and a matter of fact, our IP business unit is the youngest business unit we've had. TCAT is over 4 years, EDA is over 30 years. IP is merely since, I would say, 2019. 2018 is when we've had it. And historically was to partner up with companies that have their IP and they can't go sell those, but the IP is already tested and proven track record in manufacturing. So given that, what we did initially, we partnered with NXP, which we still have that partnership. Matter of fact, we renewed it a year ago. And we actually partnered with Samsung. We announced we were the first company ever to be able to commercialize Samsung Foundry IPs. And when we looked at that, we found out that there's an upper limit on how much of these things the companies are willing to commercialize. But there's a new need for the next level of things. So what we've done is we've expanded some of those relationships to the IPs that we know need future expansion, and we can provide that expansion. So we are doing that. But then also we found out that the future expansions that our customers are asking for doesn't exist there. So what we decided to do is add external RP or do acquisitions like Mixel that again, we focus on very unique modes, right? MIPI IP, you find out maybe there are only 2 companies in the world that can do it to the level of that Mixel does. And I think technically, in my opinion, Mixel is probably the best technical MIPI PHY companies that existed. So again, we focus on the modes that differentiate us. We focus on the areas that we are not necessarily competing head-on with our larger competitors, and we can coexist and expand our market. That's the next phase that you've seen. And the third phase is, of course, you're adding to the team. Now we have a large team after this acquisition. As I mentioned before, we've added over 100 people. We can do more kinds of IP, different flavors of it, and that's where we're at. Creating our own IP that's differentiated is where that comes up next. And don't be surprised if within a few years, our IP business unit will surpass our TCAD business unit because it has a much higher TAM than the TCAD market itself.
Okay, great. Just coming almost up on our time here. Let me just ask one question back on the topic of AI. At a high level, where's the opportunities for Silvaco in AI in terms of adding into your product line? Because if you look at Cadence and Synopsys, they've added additional products on top of their stack and so forth. Are you guys building AI into the product, or are there net new product SKUs that you can charge for that will incorporate AI?
Yeah, historically we've said, I've said there are 4 areas that AI is being utilized and will be utilized in EDA. The first one being is what we call design assist, changing the graphical user interface so that the designers can have easier, and the AI engine behind it learns their behavior and their habits and helps them get things done faster. And EDA companies are all there practically. It's pretty the first step that was done. The next step is trying to create portions of the design, like IP blocks. How much of it can be automated? So that's where everyone's working at. And the third stage, which is to me the ultimate state, can you put in a paper design spec into this EDA tool, like you do ChatGPT with text prompting, but much more intelligent prompting? Can you provide that prompt, that the design spec prompt, for the lack of better terms, to this system, and it generates a whole design for you, right? Then you don't have to have manual, and that I think is 20, 30 years away. I mean, that would be the holy relic of AI in design portion of it. The next level, as we said, we've already taken AI to manufacturing, and we are the leader in that, and that's where we are at. And manufacturing portion, again, I think it's in infancy in terms of AI for the sort of thing that's needed to do, and that's another long-term journey. I think the potential of simulations, digital twin modeling, integration of AI will surpass well beyond my lifetime. And I know that's the sort of thing that I take pride into participating and helping move forward. So.
Excellent, excellent. Well, listen, Babak, thanks very much for joining us here this morning. Thanks for getting up early, and we appreciate your insights.
Thank you very much for your time. I appreciate it. Bye-bye.